Okay, sorry this is a little late, but this is Unit 1B, Foundations of Sustainability, Ecological Principles. So we're gonna talk about what is ecology, sort of how ecology fits into sustainability, and then sort of a big picture um, idea that was developed out of one of the big Earth summits, ecological sustainable development, which we'll spend a little bit time on. Um, Remember also that there's a reading that goes with this unit that's up on Blackboard as well. So go ahead and make sure you read through that. It's not too long. There's about 4 or 5 pages of references, so it might seem long at first. Both these slides and that reading are fair game for the quiz, which I still have to write. Hopefully I'll start getting caught up soon. These slides take a while. So, all right, let's get going. So, what is ecology? So, ecology is a study of how organisms interact with one another in their physical environment. So, it's sort of grounded in biology, which is way outside of my realm. But we've all seen this. We've watched nature shows and things like that. So, a lot of this ecology is sort of all encompassing. You're not looking at any one specific animal or plant. Plants would be botany, and certain animals would be, zoology kind of thing. But this is sort of, the distribution and abundance across the earth, both biotic or living organisms and abiotic, things like rocks and minerals and stuff like that, and how they interact together, their physical, factors as to how it all fits in. So it's sort of, again, that big picture type of overlook type of science. And a lot of this kind of boils down to habitats as opposed to any one specific animal or something, looking at an entire, desert or wetland or something like that. So it's a little bit bigger scale. So why is this important to sustainability? Well, it provides the information about the ecosystems, right? That's is essentially what we're trying to protect is ecosystems, habitats, and ecology is sort of the science that has that broad umbrella of being able to, take all of this and fit it into where we need it. It provides us with information or better understanding around the world, total world, or a large continental region or even a local region. It can then help it can help improve things like resource management, environment management, protecting natural resources, and ultimately protecting humans because we live here too. All of these things play a role in this big thing that we call sustainability. So this is sort of the science behind it in terms of looking at how all of the interplay between ecosystems and even climate, everything plays a role in this. And ultimately, what can we do to protect it and to protect ourselves on the back end, so to speak, to make sure that we have those resources going forward, either for aesthetics, like a pretty park, a swamp, a bog, a forest, or something like a timber, where we're harvesting timber. How do we manage that to make sure that we have timber for generations to come? It all fits under this umbrella of ecology, and then why that's important to sustainability. Another thing that ecology looks at too, and that's seriously important for um, sustainability, is biodiversity. And we talked about this a little bit in the previous chapter, or chapter one, which was introducing invasive species and things like that. Biodiversity is a variability among living organisms from all sources. So it could be from, land, sea, air, whatever, it doesn't matter. I put this picture of the coral reef on there because it doesn't get much more, there's not much more biodiversity than at a coral reef. I mean, there's, you know, thousands and thousands of species of animals in maybe 1 square mile, or not even that much. And that biodiversity is what keeps the ecosystem vibrant with teeming. We always say teeming with life, right? You'll hear that term with scuba diving or something. So the ecological part of that is just making sure that that diversity stays intact. So you don't do things like introduce invasive species that all of a sudden take over an entire ecosystem. You don't want that at a coral reef. On the flip side of that too is that things like global climate change are affecting that biodiversity because it's warming up the oceans to the point where the corals can't live anymore, because what we call bleaching them, and it just kills off everything. So it's not just from, maybe an invasive species or something like that. It could be from pollution, oil spills, things like that. It could be from, climate change. It could be all kinds of things. So having that biodiversity ultimately again comes back and helps humans. It's important that we manage these natural ecosystems to make sure that the ocean system is all encompassing. See, everything plays a role in keeping the oceans safe. Well, we need the oceans because the oceans also provide us with a buffer from you know uh, space, solar radiation. It absorbs a lot of the heat that comes in from the sun. It affects weather because a lot of the weather, almost all the weather patterns are dictated by the oceans. The oceans cover 70% of the earth. So that's where things like hurricanes come from and tropical storms and, winter storms up in the polar regions. So all of these things interact with each other, and the decisions that humans make influence that biodiversity, like, climate change and invasive species. So we want to try to keep things as balanced and as quote unquote natural as possible. We don't want to mess with it too much because Earth has a way of correcting itself and being able to manage itself without human interaction. It did it for millions of years. Unfortunately, humans have also interacted within the last several thousand years, much to the detriment of this biodiversity. So we got to try to reverse that trend. All right, so what is ecological sustainability? And this is sort of the crux of this entire PowerPoint and the reading. I decided to go down this road rather than just looking at ecology because it's become this sort of overarching idea of how to go forward with being able to sort of clean up humans' mess. Let's look at it that way, right? So we have to clean up what we've messed up, and this sort of idea that's been developed called ecological sustainability is sort of this, laid out idea of how to go about doing that. So ecological sustainability means based on a long-term perspective, we conserve as much as we can and reduce our impact to the point where people and everything else can be elevated. People's health and everything can be elevated. Now you can see from this diagram that there's three sort of overlapping areas where you have ecology, design, and sustainability. Ecological sustainability is sort of that balance between ecology and sustainability. Obviously, that's what it says. So what you want to be able to do is between using the other two, the ecological design and sustainable design, they all play a role. If you could do one, the other two, if you can do two, the other one will come with it, or vice versa. So we're going to kind of look at the ecological part. So we want to conserve the productivity of the water, soil, and ecosystems on a long-term basis. Well, that makes sense. I always go back to the example of overfishing the oceans, right? There are areas of the world that are running out of fish. Now, that sounds very, very weird, but you can't find fish just anywhere. Reduce our impact on the natural environment and people's health to a level that natural environment and humanity can handle. So we need to reduce our our need to keep just uh, digging up and grabbing every possible resource we can without regard to the fact that we're using them up faster than they can be replenished. So we have to find a balance between, okay, do we really need to do this, or can we reuse or recycle? That's where a lot of that comes from. And then finally, take a long-term approach to sustainability as our starting point. So when you're talking about products, production, resources, climate, that ecological sustainability should be at the forefront when anything is being proposed. That's what they're trying to get at here. So the idea is before you ever create the product, have this sort of paradigm, this whole idea of ecological sustainability in mind when you design the packaging, when you do the marketing, when you're, developing the product. How can you do it to make sure that it's sustainable? All of these things play a role. And a lot of times in business, business is about the bottom line, right? They want to make a profit. And that's where that fine line comes in, and that's where that's going to be a common theme throughout the semester is where is that line between profit and productivity, and then have keeping these type of ideas, the ecological sustainability in mind. So if you have a sustainable design from the get-go, or an ecological design, then ecological sustainability will come much easier. So it's kind of like, if looking at this diagram, if you can achieve two of them, the third will come easier. All right, so that's sort of the idea with this whole ecological sustainability. So here's one of those crowd diagram things that shows you the type of um, questions and things that need to be accounted for when dealing with ecological sustainability. I understand some of it's um, covered, but you get the idea. So you see ecology there right up front and center. Sustainable, renewable energy, electricity. You see renewable a few times. Geothermal, there's turbine in there. If you look closely, resource fuel, hydropower, windmill, you get the idea. So all of these things are factors that could be built into a sustainable ecological model. So that's why I kept this particular diagram to kind of show you these are what goes into all this. You can see solar in there and innovation, and so there's a lot of this being done. There are a lot of companies out there that are trying to uh, build into and create a business out of these type of ecological sustainable ideas. I'll learn how to pronounce that eventually. So another thing that we have to keep in mind is ecosystems, obviously, and their services. And what does that mean? Ecosystem is defined by the planet's boundaries, right? So we have certain areas that have deserts, certain areas that have, polar regions, and it's kind of dictated by where you are on Earth. Okay, and those boundaries are for all life on Earth. The services of the ecosystems are things like biological diversity, pollination, food production, things like that, where you have to sort of live within those realms depending on where you are. If you're in a temperate climate zone, you can't expect to have certain biodiversity that you might have, let's say, in a desert. It's going to be different, and you have to live within that particular ecosystem. So to ensure that the development goes into the right direction, we must make long-term sustainability an issue in policies, products, production, and resource efficiency. Again, all when you're coming up with the ideas, and when you're trying to build something, these types of these types of ideas need to be in place going forward. And again, in the past, this was never the case. You had an idea for a product, you just went out and did it. I mean, look at the Industrial Revolution, right? You had the steel mills and all of this. They had no regard whatsoever for the environment. They just, they just looked at bottom line profit. Make more, make more, make more, make more. And the unfortunate reality is that mentality is prevalent in business for obvious reasons. They want to make a profit, or a business isn't going to stay in business very long. But nowadays, you can't just get away with just, pumping all that crap up into the atmosphere and getting away with it. There's a lot of more rules in place. So there are ancillary or other decisions that need to be made in order to make sure that A, you're playing by the rules, but B, you can sustain this over time and be sort of, you hear the term all the time, green, right? A green company. And that's sort of where a lot of this comes from. You know, uh, they're trying to reduce their environmental footprint. hopefully you've heard these terms before, and that's what all of this is being built into. So that's where the policies, products, and production and resource efficiency come from. As a business, how do we make those decisions to make sure that we're not using packaging that's not going to biodegrade for 3,000 years. You still buy products out there. Look at like batteries, right? Batteries come in that super heavy plastic. Maybe there's a reason for that, but I find there's a lot of over packaging. I just bought something, an antibiotic type medicine that comes, you look at in this big tall box, right? And it's a tiny little tube. So it's like, why do you need that big box to have that tiny little tube? And it's just weird. I don't understand uh, why they do that. Probably because if people knew they were spending, it's like 12 bucks for that tiny little tube because it's strong stuff, but they wouldn't buy it if it was in a tiny little box. I don't know. So, consumer psychology, I guess. So, the Millennium Ecosystem Assessment, which was a United Nations sponsored effort to look at these things. So we have these supporting services. So these are the ecosystem functions. So nutrient cycling, evolution, soil formation, spatial structure, primary production, right? And then within that, you have all of these smaller um, uh, services that are, sort of subdivided. Now the next diagram I'm going to show you actually shows it a little bit better, but I wanted to keep this one because it's kind of clean. So things like provisioning, regulation, cultural, and there's another one actually that we'll talk about in a second. So within these big picture things, you have things like food, fresh water, fuel, wood, fiber. That's the provisioning, what we use as resources and how they go back to supporting the ecosystem. How do we keep the fresh water fresh, right? How do we use the wood and the fibers and the biochemicals, but we make them sustainable? Then there's the regulation side of it, so to speak, regulating things like climate, floods, disease, water regulation. So this is protecting both with policy and just sort of common sense the resources that we will need for the future. And then there's the cultural ones, and these are the tough ones. These are sort of the ones that, are hard to get through because of cultural barriers. It's sometimes hard to explain to somebody who knows nothing about these concepts, hey, you shouldn't do that. Well, they're doing it to survive. So things like spiritual, religious, ecotourism, aesthetic, you know, golf courses, for example, or, people watering their lawns like crazy in the middle of the desert in Arizona, stuff like that. All right. So let me show you the next slide, and hopefully this will make a little bit more sense. All right, so here's a better slide showing the four major subdivisions of ecosystems and their services, and then you can see within there that there's a bunch. So you have the supporting services, so things like soil formation, biodiversity, habitat, and photosynthesis. So those are sort of the natural part of this whole ecosystem, the kind of stuff that is out there in the wild, so to speak, where we as humans don't live, but we're ultimately trying to protect. You have the provisioning. How do we get clean water, clean food? I know that sounds weird, but it's true. Clean food, medicines, and raw materials. So how does the ecosystem provide that, and then how do we use those resources but still be able to protect them? The cultural side, like I just mentioned, things like aesthetics, making things look pretty. That's what that means. Spiritual, recreation, and education, trying to keep everything the way it is from a human aspect. We have, there are areas of the world that have very strong spiritual ideas about what the environment does. Native Americans have always been that way, very strongly tied to the environment. All right, there are other areas of the world where, they look at the environment very differently than we do. Good, bad, or otherwise. I'm not passing judgment. That's not it. It's just things are looked at differently. So if you go in there to some other part of the world and they're to them that, this creek is fine just the way it is, but you look at it and you see, needles floating down the water, that's a problem. But how do you explain that to somebody who says that river is our spiritual guideline? I'm making all this up, but you get the idea. It's very difficult to sway somebody when it's sort of built into their bones and their spiritual nature. And then finally, you have the regulating part, things like flood control, climate regulation, stuff like that. And that's the human impact on the services. How do we mitigate that? How do we reduce that? And all of those are going to play a role. Now, I'm going to tell you right away that this slide is going to be part of the discussion. All right, this is you're going to take 1/4 of this and then describe a bunch of stuff. So make sure you look these things up, do a little bit of internet research if you have to, and no one sentence answers, please. So I thought this was a very cool diagram to kind of show you the various roles that the ecosystems play, not just from a habitat standpoint, like, where the little critters live, but when you look at one ecosystem, there's a lot going on. And that there's those four major divisions, and within that, all of these decisions that need to be made. And you could say that for every ecosystem, all of these things apply. How do we keep a swamp, a marsh intact? We have the Horicon Marsh just north of here, and it's a beautiful area. All of these things play a role, all right? And some are more applicable than others. Maybe it's not a spiritual place to most of us, but definitely it's a recreation place. So there's still that cultural service being represented because it is a park and people go visit it all the time. Never been there. It's very pretty, by the way. Lots of cool birds and stuff like that. All right. So make sure you understand this slide. If you have to, you might have to go do a little bit of digging online to see what else is going on with this. But I thought this was a very, very cool diagram. All right, so we're going to dive into the ecological sustainable development, um, this big idea. And I don't want to call it a theory or anything like that. It's more of a sort of a policy-driven uh, way of looking at ecological sustainability. So the World Commission presented a report in 1987 called Our Common Future, and they sought to address the problem between environment development goals. That's always the issue, excuse me, right? How do you manage what humans want to do with the environment with what the environment needs, all right? How do you tell somebody they can't cut down these trees to grow crops so they can live? And that's what's going on in the Amazon. We've talked about that. So the idea is, in a nutshell, sustainable development is development which meets the needs of the present without compromising the ability of future generations to meet their own needs. That's huge. That statement right there is all of this in a nutshell, pretty much everything we've talked about. All right. Sustainable development, I'm going to repeat it. Sustainable development is development which meets the needs of the present without compromising the ability of future generations to meet their own needs. So this is a big departure from what had been done in the past, right? In the past, we had just, gone out and done whatever we wanted, make that profit, do whatever we do, and then not even realizing what kind of damage we've done to the environment around us. Well, over the last, 40 years or so, now this report came out in 87, all right? So that was a long time ago, probably before all you were born. I was in just starting high school. Um, I was a sophomore actually. So this came out quite a while ago, and since the 70s, 60s, and 70s, and we talked about this way back in the beginning, chapter one, the attitudes towards this and the policies have started to change, right? When I was a kid, there was no recycling bins. You just threw everything in the garbage. And then all of a sudden now you had to start separating your aluminum cans and glass bottles, and it went from there, paper and everything. So it's been incremental over the last 30, 40 years. Um, and now we're just kind of used to it. We just do it. On Mondays I take out my bins to the road, right? And and I'm very, very adamant about recycling, because it's just you know, am I perfect at renewing or being wasteful? No, I'm not. I don't think most, especially Americans, are. But I am adamant that if I could do some small part, it's so easy to just take your aluminum cans and throw them into the other bin. Why just throw them into the garbage? So I try to recycle as much as I can. So this is sort of, like I said, this whole idea that they came up with back in 87, that's been sort of implemented again over time slowly. So there's a lot of reading in these slides. I'm not going to read all of it, but please make sure that you look through these carefully, because again, this is all fair game for the quiz and everything. So there's three aspects of sustainable development that came out of this report. The first is economic, right? And that's huge. How do you sustain a system that must produce goods on a continuing basis, but still manage the level of external debt, avoid imbalances and things like, you know, damage to agricultural and industrial production? There again is that fine line. How much can we do without completely destroying the environment? How much is enough? Do we need to, overproduce everything? In America, we have a tendency that, go big or go home, right? That's sort of an attitude that Americans have. Um, so the idea again is, how do you balance the between producing goods without just completely destroying everything to produce those goods? I hope that makes sense. The next one is environmental, and obvious. This should hopefully make total sense. How do you you need an environmentally sustainable system that must maintain stable resource base, avoid exploitation of renewable systems, and things like that. Okay, we don't. We need to be able to slow down the extraction of non-renewable sources by utilizing more renewable sources. Non-renewable sources, unless if they completely dry up, they're not going anywhere, right? What we're trying to do with things like solar and wind and biofuels and stuff like that is slow down the extraction to manageable levels, of oil and coal and natural gas, things like that. What that does is twofold. It creates new businesses to do new things with things like wind and solar. It slows down the production of the um, non-renewable sources, which a lot of those processes also in turn create pollution themselves. Burning coal, all those types of things, gasoline, making gas, our cars. Okay, so the way to do this is, but things like maintenance of biodiversity, and we talked about that. Biodiversity is hugely important. Atmospheric stability, again, this is an ongoing thing. Cars, factories, all of this play a role. And you may not think so, but cars nowadays are a zillion times cleaner than they were when I was a kid. Okay, we used leaded gas when I was a kid. So, we used leaded gas up through the time I had my first car, and that would have been like 91, 90, 91, somewhere in there. So, though, the rules have changed so much that the environmental impacts have lessened. They've gotten better, but not to the point where we're actually using more non or renewable resources, excuse me, than non-renewable. That's going to be a battle that's going to go on for years to come. With the advent of things like electric cars and stuff like that, um, there's still a balance there, right? It takes a lot of energy to create those batteries that they use to get around, but on the flip side of that, there's zero emissions. So there's a trade-off there. Um, I would love an electric car. I mean, who wouldn't? Who wants to put gas in a car all the time? It's just not practical for me because I need something like an SUV. It's just with my life and what I have to do, I'm a pragmatist. And what that means is I use it as a utility. All right. I carry my drums around. I have to take sticks and things to the dump all the time. I can't do that in a tiny little car. I can't. So for me, it's not practical. But if you made an affordable, reliable electric US SUV, which it'll happen eventually, I would consider it. Why not? I mean, like I said, who wants to put gas in their car all the time? All right, and then finally, the last aspect here is the social one. And again, this is the one that is the most difficult to get people to buy into, and that's distributional equity, health. Making sure humans have health and education and stuff like that. This is a much more nebulous concept, and what that means is, you can understand what biodiversity is. It's sort of cut and dry. Okay, we want to keep all the habitats and the ecosystem sort of as natural as possible. But again, when it comes to humans, changing a human's mind depending on what their belief system is, that's a whole different ball of wax, and that's where politics and policies and things like that come in, and it's not that easy. And that's why the changes that have been made over the years since the 70s, 60s, and 70s have been incremental, because it does take time to change people's attitudes towards things like recycling. I'll just use that as an example. Like I said, we didn't do it as a kid, but now it's second nature. I mean, seatbelts. There's another example. When we were kids, when I was a kid, we never wore seatbelts ever. We Nope. But now, I never leave the house without putting my seatbelt on. It just makes sense, right? I mean, it's just what we've been told to do over the years, but it is common sense. So I've already mentioned this. I figured under this ESD, the Ecological Sustainable Development, I wanted to put it up here one more time. The original concept is that the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Now, I put that up there again, so that the slides following this one are all taken from this gentleman who wrote up sort of not only what this it encompasses everything that this sustainable ecological sustainable development um, is about. And there's a lot of reading here, and I'm not going to read it right off the slide. I'm going to try not to. But you'll also hear me call it ESD. It's just easier. Ecological Sustainable Development, ESD. So if I say ESD, that's what I mean. Okay, so it involves a cluster of elements or principles, and there's more than six, but these are three or six of the main ones, and we're going to go through each one of these. So sustainable use, the principle of integration, precautionary principle, which is really it's both important but also controversial, and I'll talk about that a little bit. Intergenerational and intragenerational equity, and we'll talk again. I have slides for all of these. Conservation of biological diversity and ecological integrity. We've been talking about that already. And then internalization of external environmental costs. So that's sort of the trade-offs between profit and, nature, so to speak. So the first of these six principles is the principle of sustainable use. So looking at natural resources should be used in a manner of which is sustainable, prudent, wise, appropriate. How do we best use the environment, but not merely to develop, but to sustain? Sustainable means, using the components in a way that a rate does not lead to long-term decline of biodiversity. And things like deforestation and overfishing, polluting and things like that. These are the kinds of things that are only going to be used as a detriment. We have to figure out ways to not do this going forward, um, to meet the aspirations of future generations. So we've been talking about this, and this is the easiest of the principles to understand. Don't overuse the environment. Live within our means, so to speak, with when it comes to the environment. The next principle is the principle of integration. So ESD requires effective integration of economic and environmental considerations in the decision-making process. And that's what a lot of the principle of integration is combining the needs of the environment with the needs of, let's say, profit and the decision making that goes between the two. So things like, making sure that the ecological cycle isn't harmed by economic development. So many times we've had issues with going and getting natural resources and then having a cost 4 or 5 times more to clean up the mess. And that's a huge thing that's been, an ongoing problem for hundreds, a couple hundred years now since the Industrial Revolution. Is, yeah, we can go get that coal, we can go get that gold, we can go get whatever resource you need, but now we realize all the damage that's been done costs more to fix than it did from the profit that you actually got from the resource itself. Unfortunately, that's a big case in the mining industry. Now, mining practices now are highly regulated, so they can't get away with the same stuff that they did 100 years or even 50, 60 years ago. But the damage is, in a lot of those places has already been done, and it costs more to clean it up than it did from the profit that they actually extracted from the ground. So this principle of integration also ensures mutual respect between economic and environmental considerations. So they have to go hand in hand. And when I made this slide, those little icons there automatically popped up, but that's a perfect example of figuring out the between economic and environmental considerations that they have to go in hand in hand. If you're gonna go get some type of environmental resource, you can't do that without asking the questions about the environmental development plans that are going to go into it as well. So environment and economic policies need to be hand in hand and always go together when those decisions are being made. And then you have the social development part of it too. So how does it affect, let's say, a community or a group of people? And again, this was something that wasn't considered, let's say, 60, 70 years ago or in other parts of the world. Now we're only speaking from America's point of view, but there are other parts of the world where they'll go in and mine and displace entire villages or cities to get at that resource without even blinking an eye. This has been done in places like China. When they built the Three Gorges Dam, for example, if you read that story, they moved entire cities to build that dam. And then the dam, there was a whole bunch of environmental issues with that dam. And so the Three Gorges Dam in China is a great, unfortunately, a great example of what not to do in a lot of these aspects. So another huge principle is the precautionary principle. Now, you may not have heard of this in name, and in fact, when I looked this up, I didn't know what it meant at first either until you start reading it. Now, I don't know where I stand on this. All right, it can be somewhat controversial, and I'll explain this as we go. But if you look at the image on the left there, you could see again, preventative, uncertain, irreducible, irreversible, potential. There's all kinds of stuff in there. Modified, safety. In a nutshell, what this is if you read that first bullet point, if there are threats of serious or irreversible environment damage, lack of full scientific certainty should not be used as a reason for postponing measures to prevent environmental degradation. Let me read that in English. Basically, if one person says this could really harm the environment, you shouldn't do it. And that can be dangerous. Um, I'm a scientist. I've been trained to be a scientist. I have degrees in science. So this kind of goes against what I've been told my entire career. Where you investigate, you look at all possible angles, you get peer reviewed, which means you have other people in similar fields look at it to make sure your science is correct. And essentially what the precautionary principle is saying is if you even think this is going to be a big issue, don't do it. And that's tough. That's really hard. If you're trying to build a business and you think you're doing everything right, and you got one person that says, "Hey, wait a minute, this is going to screw everything up possibly." And that's the big key with this precautionary principle, is that this is all possible. It's not been proven. And in science, we like to prove things. So the application of the precautionary principle is that public and private decisions should be guided by careful evaluation, um, serious or irreversible and assessment of risk, weighted consequences, and various options. So what that means to me, from a science point of view, is people who like to build models without actually doing science in terms of, you know, it's weird. It's very contradictory to what I've been told my whole life, pretty much. Now, if you read the final bullet point, and I wanted to make sure I put that in there, it should not be viewed in isolation, but rather as part of the entire package. Precautionary measures selected should not be only appropriate having regard itself, but also in the context of other principles. So what they're saying is while the precautionary principle is part of ecological sustainability development, it shouldn't be the deciding factor. Now think about that for a second. Think about today's social media circus, that is things like Facebook and Twitter. If one person says something, all of a sudden it might go viral, right? So let's say I have an idea for a product or something, and I say, I want to build my widgets here, and one person goes on a social media outlet and says, I can't believe they're doing this. This is my favorite piece of land, blah, this, that, or the other. It's going to destroy everything. Well, where's the proof? But the problem is now you have, you know, the the social media, you have this, it's already out there, and people are going to sort of judge without having proof. And that's part of the problem with this precautionary principle, is who is making these assessments? Is it policymakers with a degree in science that have the knowledge of everything that's going on with the environment and ecosystems, maybe some biologists or ecologists or something like that? Or is it, the general public who have a tendency to make decisions based upon their heartstrings, their feelings? And that's really tough. You got to be very careful not to allow this precautionary principle to be the guiding factor, but a factor in a much bigger picture. So when I first started reading this, I'm like, oh, I've heard of this. I just didn't know it had a name. And now you see this kind of stuff pop up more and more and more, where you have one person who has an objection to something, and all of a sudden everything stops because they have to look into it further, even though there's no scientific basis or fact when it comes to it. So this is one in this whole thing that I found interesting, but I'm very cautious about because of my scientific background. Science has always, for the most part, been peer reviewed. And again, I go back to that because if I present a paper, and I have done that, I presented earthquake research, I've presented other kinds of research. Other people in that field look at it before it ever gets out to print. They want to make sure that I'm not doing screwy science. And the unfortunate reality is when it comes to stuff like this, especially with environments, people get very, very defensive quickly, and all of a sudden decisions can be made based not on any factors other than somebody's feelings. And you got to be very careful with that. So there are some conditions that go into this. All right. With this precautionary principle. And there's what's called the first condition and the second condition. So it's not necessary that serious or irreversible damage have actually occurred. It is the threat of such damage that is required. The environmental damage threatened must attain the threshold of being serious or irreversible. Again, that's a very subjective line. Who determines where that line is? Okay. And that's part of the problem. That's what I was trying to get at. That in a nutshell is who makes that decision that it's irreversible. If somebody really cares about or has a beef with somebody else, they could say, oh, the damage is going to be irreversible. And once people hear that, they've already made their minds up. The threat of serious irreversible damage must be adequately sustained by scientifically plausible evidence. Well, that's good, right? We want that. The condition will be fulfilled when empirical scientific data, as opposed to simple hypothesis or intuition, make it reasonable, make it a reasonable scenario, even though it does not enjoy unanimous scientific support. So that last part right there does not enjoy unanimous scientific support. Again, I have a problem with. Because if you have one scientist who has an agenda and it can override 50 other scientists who don't agree with similar backgrounds, that's not how science is supposed to work. So that you got to be very careful with this. This is a very fine line here. And as I was developing these slides, I'm going, oh my goodness. And unfortunately, you do see this more and more, because it's more agenda driven than science driven. So there are also second principles. So if the first principles are met, then you kind of go to these second principles to ensure these are sort of the checks and balances, if you will, for the previous slide. So as leery as I am about this, at least with this slide, there's some, okay, if this happens, then, or if this doesn't happen, even though the first condition might have been applicable, if the second condition is not, that's kind of what these slides are getting at. So the degree of scientific uncertainty that needs to trigger the precautionary principle varies depending on the magnitude of the damage. And you got to be careful with that because, again, that's a bit subjective. If you have 5 scientists who all are ecologists, one might say, wow, I can't believe they're going to do that. That is just going to completely screw up the environment. And the other 4 might look at them and go, really? Seriously? Maybe a little, but not as much. Again, you have to be able to balance what your agenda is as opposed to what the science dictates. All right. Now, if there's not considerable scientific uncertainty, okay, then but there is a threat. So if the second condition is not satisfied, if none of these are satisfied, but the first one is, then the precautionary principle can't be applied. So that's, again, this checks and balances. You need the second condition to apply in order for the first condition to take effect. The previous slide, that is. And that's good. I mean, that made me feel a little better as I was going through these. Um, and if the second condition doesn't apply, but the first does, you can still take measures to regulate, the seriousness and, any type of damage that may occur. So just because the second condition does not apply, that doesn't mean you can't take at least some steps in, making sure that there isn't total irreversible damage being done when appropriate. Yeah, this whole condition precautionary principle is very, very odd. Okay, and I understand that. Hopefully, I'm explaining this correctly. I read over these slides quite a bit to understand what I had to come on here and say. So let me recap real quick, going back to the previous slide. So you have this idea with the precautionary principle that if there's a threat, even a threat of irreversible damage, sort of you need to kick into gear that something needs to be done. Okay. But because that is so highly subjective in the fact that it doesn't need unanimous scientific support, which scares me, okay, you have this second condition that states, okay, fine, how much damage is being done, what is the magnitude, okay, and is it within scientific uncertainty, and then if the second condition does not apply, you cannot apply the first one other than maybe some basic, regulations, in terms of, whether or not there's going to be damage done, but you can't pinpoint it. Maybe you can do some regulation anyways. Now, the unfortunate reality is in all this, and I've seen this through the news and being in science, is a lot of times the first condition is the only one that's ever looked at. Again, it becomes the court of popular opinion. If somebody comes in and says this is going to ruin the environment, they just go with it. It becomes viral, just like we would say in social media. It becomes viral at that point. And things like the news media and stuff like that don't help the situation with the way they word things, the way they cover things, because as a scientist, it drives me crazy because all they do is they come out and say these quote unquote facts when I know for a fact that the science in the background, if done properly, probably would have said, no, that's not true. But the headlines don't read it that way. So the general public only gets a small part of it. And you could say that for a lot of things. We got an election cycle coming up. You believe what you want that you see on TV, right? I turn most of that off anyway. But the point is those commercials are designed to sort of put it in your face and make you remember it, um, whether you agree with it or not. But that the idea is the same with this. The environment. Just be aware that these conditions are vital and a part of the ESD model, but they're not the only part. Although this is unfortunately sort of how a lot of this stuff seems to get done nowadays. So there are some other factors when it comes to the precautionary principle that aren't necessarily the first or second condition that where things kick in. Um, and I'm not going to go through all these. You have to make sure that you retain that a margin of error. There has to be some wiggle room. It's not black or white, yes or no. There's got to be some wiggle room in there. All right. Because a lot of times, if you build a building, we'll just use this as an example. I have a new factory I want to build, and just the land that it's going to be built on, there's going to be environmental impact no matter what. Okay, I'm taking an area that was normally natural and I'm putting a big slab on it with a big factory. So I'm going to impact the environment no matter what. The problem is you have to balance that with sustainability and to reduce that environmental impact as much as possible. All right. Well, whenever there's a big building being built, usually a lot of times somebody has a problem with it, whether they consider it an eyesore or they just don't want it in their backyard. Even windmills, right? This alternative energy source that we have of windmills, a lot of people hate them. They just hate them. They consider them eyesores, and they don't like what it does to migratory birds and all this. They just don't want them anywhere near their house. They think they drop their property values, all kinds of stuff. So that's where this, you have to balance it out. So if you read the second last one, considerations of practicability need to be taken into account. There must be a proportionality of response or cost effectiveness of margins of error that show that the precautionary measure is not unduly costly. So, in a nutshell, what that means is if I want to build that factory, are the regulations going to bog me down so much that it's going to economically throw my entire thing into the garbage because it'll cost me more to build that with all the environmental considerations than it would to just not build it at all. And that's one of the things that again goes back to that balance. Yes, we want to have the economic sustainability development sort of model in place, and because we don't want to just willy-nilly screw up the environment, right? But if I'm building a factory and I'm going to create jobs and I'm going to do all of these things for the environment, or excuse me, the economy, I don't want to be bogged down by the little details of the environment. I will do my best as the person building this thing to make sure that as little impact is being made as possible, but not to the point where it's going to cost more to mitigate those impacts than it would be to build the building itself. And that's a fine line. I mean, there's a lot of new regulations. Let me give you an example. If you've noticed, not everywhere, but a lot of times when they've been rebuilding the freeways over the last 10, 15 years, right? In some areas you'll see these huge areas that are retention ponds now. Okay, so when it rains heavily, they fill up with water somewhat from the freeways. All the water's diverted in there. That never used to be like that. Those are being built because the regulations dictate that they have to. So because of all of the cement, all on the freeways, the water has nowhere to go. They don't want it in the natural water system, so they build these big retention ponds and then let it settle out. And a lot of the pollutants, if because there are pollutants on the road, cars leak, there's gas, garbage, whatever. A lot of that's taken up by the ground, and then by the time it trickles down, a lot of that stuff's been removed. And it's a flood preventative measure. So if there's so much rain, the water on all of the freeway systems would have nowhere to go. So it could go into your basements and things like that. So they've built these big ponds now, and you may have noticed them, you may not have, but you will now that I mention it. Now, the final bullet point is the big one about this whole precautionary principle, and I'm going to read it. I'm going to look on this screen just because it's bigger. The precautionary principle, when triggered, does not necessarily prohibit the carrying out of a development plan, program, or project until full scientific certainty is attained. That's the key to this whole thing. It the precautionary principle should be there because you want to minimize your environmental impact for any type of development, but it shouldn't be the only thing that would prevent it. That's where the checks and balances come in, and the other aspects, the other principles that we've both talked about and we will talk about. So the precautionary principle, I spent a lot of time on this because I want you to understand that the unfortunate reality is in the court of popular opinion, this does become a huge part of the development plan when in theory it's not supposed to be. It's only supposed to be a part of it. All right. So another principle of the ESD, or the environmental sustainability model development, is intergenerational and intragenerational equity. All right. So intergenerational equity requires the present generation to ensure the health and environment for future generations. Okay. So leaving the earth better for my kids than it was for me. All right. Now, that makes sense. We've been saying that for years. All right. Have we done that? No. Have we gotten better at it? Yeah. Like I said, when I was a kid, life was a lot different. There was no recycling. Nobody cared at the time. And it's weird. It's hard to say that. It sounds weird to say that. But over the last 30, 40 years, the mindset has changed incrementally, that hey, these little tiny environmental questions need to be, leaving the water run when you brush your teeth, stuff like that, right? Back when we were kids, and I still yell at my kids for doing that. It just seems silly. Why? Not only that, I'm paying for the water. All right. Intra-generational equity involves considerations within the present generation. All right. So my generation now, as we live, needs to do better at these, uh, sustainable development decisions now, because what happens now will impact the future, right? So we need to work on it now. It's not something we can push off for future generations. And the unfortunate reality is politicians love to push things off because they look at voting cycles. Okay, I'm not a big fan of politicians, if you haven't figured that out yet. I'm just not. They all have agendas, obviously, and that's what they do. They work towards the next voting cycle. So they push things off. There's a lot of non-commitment in voting in things like the Congress and House of Representatives because they don't want to, for lack of a better term, piss off people. So they don't. That ensures that they get elected again. That's how the game is played. I'm not a fan of it, but that's how it's played. So the use of natural resources by one country needs to take account with the needs of other countries. This is huge, and you know, we've become a global economy, whether you like it or not. I mean, you can't go into, you could barely go into the stores and buy anything made in America, right? It's all made in China, pretty much. Go to the dollar store and find something that was made in America. It's just, it's impossible. And I'm not mad about that. I'm just saying it is a global market. So we need to make sure that there's sort of this equity built in, that other countries besides the most developed ones, like the United States, Canada, Europe, China, they're kind of glomming onto all of the resources, whereas the developing countries are sort of left in the dust because they don't, let's say, have the buying power to utilize them. Now, intra-generational equity involves people within the present having equal rights to benefit the natural resources and clean and healthy environment. And I kind of just touched on that a little bit. All right. So making sure that those that are in maybe in a less developed nation still have access to health and all that, better health and in natural resources than developing countries. And we know for sure that's not the case, right? A developing country is one with an economy that just isn't there yet. But because of countries like, well, US and Japan and China, we're fully developed. We use so many resources that there's not a whole lot left in that pie for the developing countries to sort of get ahead. And that's where this whole principle is coming from, is sort of spread that out a bit. Another principle is conservation of biological diversity and ecological integrity. And we talked about this, right, a little bit. Um, Making sure we're using conservation techniques for biological diversity. Um, it has to be an integral consideration when decision making is taking place. All right. And again, I go back to the building, if I have this factory I want to build, by all means, there should be environmental and biodiversity impact studies being done, but not at the detriment of, you know, to the point where it's cost prohibitive to even build the building itself. All right. Things like genetic diversity, species diversity, and ecosystem diversity, all of these things must be taken into account in the decision-making process for whatever it is, whether it be a subdivision or conservation of an area to ensure all of these take place. Maybe building a new park, for every tree cut, you grow one. All those decisions are part of that biological diversity. And those decisions have to go hand in hand with the economic side and the planning side of, okay, where am I putting my building? Do I have road access to that building? So those are sort of the practical decisions that need to be made, but right alongside them in parallel, they need to be the ecological decisions need to be made as well. And so the last principle we're going to talk about is internalization of external environmental costs. Again, it all boils down to money. If I'm building a business, I need to know that I can do it in such a way that I have to make a profit, because without a profit, I won't have a business. Okay? So those costs, those environmental costs, have to be built into the decision making of any economic or other development plan, um, both for short-term and long-term environmental costs. You want to try to look into the future, so to speak. We talked about backcasting, looking all the way down at the end game and working backwards, to see, is there going to be more environmental impact than we planned for? Now, if there's pollution in play, taking place, the polluter should have to take care of that problem. And there's a lot of times that isn't the case. You know, things like containment or abatement, where you're, building structures to keep things from getting further polluted. Um, the users of goods and services should pay prices based on the full cycle costs providing those goods and services. What does that mean? Well, if this was the case, everything would cost a lot more. And it's one of the reasons so much is being done in China, because in China, they have much more lax rules for how they make things, both from what they pay their people to the environmental concerns. So that's why stuff made in China is so much cheaper. They can mass produce it with a lot less regulation. You know, that's the problem. People don't want to go to Walmart and pay more. They want to go to Walmart and pay less. I don't go to Walmart. I hate that store. Um, so environmental goals, having been established, should be pursued in the most effective way by establishing incentive structures, market mechanisms that maximize or minimize costs uh, to develop their own solution and responses to environmental problems. What does this mean? If I'm a company and I'm building it from scratch and I take into consideration as many possible environmental impacts as I can, I should be rewarded for that, maybe in tax incentives and things like that over years. If I'm going to take the time and spend the extra money to get all these environmental things in place, then I should be rewarded on the back end to maybe recoup some of that by, maybe lower taxes and things like that. And you actually already see this a little bit. If you buy certain cars and stuff like that, you can get a tax credit. If I think on electric cars, I got a tax credit on, I believe, my new furnace. When this was like 8, 9 years ago, but I bought a high efficiency furnace. Ours was making mini explosions. I had to replace it. So I bought a high efficiency one, and that's the way they're built now. And based on, if you look at your tax forms, there's little things like that that you can do. And one of them too is cars. Like if you buy an electric car, you get an energy credit for that. And you should. All right. Again, I would do it. It's not practical for where I am in my life right now. Maybe in 20 years, who knows? So this is absolutely the case. You should be rewarded for taking the extra time to make sustainability at the forefront of your entire development plan. All right. But again, if I'm a business and I do that, I should be rewarded. Otherwise, I'm not going to make a profit and I'm going to end up going out of business. So there's the fine line between profit and sustainability. All right, so there's a lot of weird concepts going on in this particular unit. Um, I learned a lot out of this. I didn't know some of this stuff. The precautionary principle, not to beat a dead horse, that one kind of scares me a little bit because you actually see that type of stuff if you're in the news, watch the news and things like that. And that whole precautionary principle boils down to the court of the public opinion. And with social media, it kind of spooks me a little bit in terms of, where's the science involved in it. But it's good to know that there are also checks and balances and that, they're adamant that precautionary principle is not the guiding factor. It's just one of many. So I hope you learned something out of this chapter. I certainly did. Some of this stuff was new for me, and I hope that between this and the readings, the reading of that paper, obviously this is not in the book. Anything on the test will be on these, pretty much out of either the reading, but mostly out of these slides. I spent a lot of time on these slides trying to get this sort of worded correctly and everything. And I hope you enjoy this chapter, and I'll see you in chapter 3.